Hello and welcome to another episode of the Fully Charged Plus podcast. This week we're talking about battery safety. Really, I think fairly critical a topic as we transition to not burning fossil fuels. Basically, if we're going to store energy in batteries, there are sort of intrinsic dangers whenever you store energy in anything. You know, and it's volatile stuff. So you have to be careful. And that's what is really brilliant about this, kind of getting in there early. You know, I make the caveat during the recording, but I mean, I think it's important to say, and I've actually got the statistics, and I'd just like to repeat them for you, because I think it's quite an interesting thing. Because the other day I had a tweet from someone who just said, "Oh, I'm not going to get an electric car. They're always bursting into flames." And you go, well, you know, there's dangers in all technologies, no question. But here's the latest comparative figures. That is that there are 55 fires for every billion miles driven. So, you know, not many. 55 fires for every billion miles driven in combustion cars. So, you know, you drive a billion miles in your combustion car and it will burn 55 times. Billion, not million, billion with a B. So, you know, it happens, but it's very, very rare. We know that. And electric cars, it's 5 fires per million miles driven. So it's got nothing to do with the number of cars or all that. It's exactly the same metric. An electric car has to drive a billion miles, and in that time, it might catch fire 5 times. There we go. So that's just to put that into context. That's from research done in the United States recently. So what we're talking about today is exactly that. So we're with this wonderful man called Joe Holdsworth, who I did meet many years ago on a completely different project and show and everything. That will all be revealed in the episode. Before we go over to Joe, who's founded a company called Metis Engineering. So that we're talking about this company that has developed amazing sensors. You'll hear all about it in the show, and it's not just about in new vehicles like buses, cars, trucks, taxis, all that stuff. What about second life batteries? Really, he makes some really good points about the safety of second life battery usage. So really top quality stuff. Just want to quickly remind you that Fully Charged Live UK at Farnborough International on the 29th, 30th and 1st of May. Tickets are available now. Thousands of test drives. If you're over 25, you can pre-book a test drive in a Polestar. Unfortunately, we just found out that because there's a student really wanted to have a go and he's only 19 and you have to be 25 to have a test drive. But that's not in all the cars. It definitely is Polestar. This show is looking like a behemoth, like an absolute mega. It's a mega event. That's the only way I can describe it. Fully Charged Live UK is going to be a mega event. We've a lot more information about it coming on the Fully Charged show in the next few weeks. There probably will be on the next few years as well, but about this specific show, next few weeks. And then that is quite swiftly followed, not that swiftly, by the newly moved dates of Fully Charged Amsterdam, which is equally exciting. We've just had some reports back from our Dutch team that are working on that. It's going to be great. It's going to be amazing at the RAI in Amsterdam on the 20th, 21st and 22nd of May. So I don't think I said the dates, did I, of the English one, the British one, 29th and 30th of April and the 1st of May. So that weekend. And then Amsterdam is a few weeks later, and it's just brilliant what's going on there. So those two things, we're very excited about that. Forgive us for being excited about the live shows, but they are really amazing experiences. This will be our 5th show. Is that right? 1, 2, 3, 4, 5th. Yes, our 5th ever show, 5th and 6th show. And then later this year, we're in San Diego in California. And then, as I've mentioned before, earlier next year, March of 2023, we're down under, Sydney, Australia, mate. And that is going to be amazing. But we won't talk about that now. Can't get excited about that now. Before we start, though, let's just have a little bit of an update from our wonderful sponsor who make this podcast possible for you to listen to. We're very grateful to them. Let's have a word from My Energy. My Energy is putting the I back into British innovation. My Energy is putting the I back into inventing the future. My Energy is putting the I back into inspiring a nation. Recharging the world with green, smart energy. Charge your EV with your PV and more. Visit myenergy.com and help to spark the green revolution. My Energy, driving the charge to a greener future. So, Joe, thank you very much for agreeing to come on the Fully Charged Plus podcast. I just want to say that I find this is a critically important topic, because I worked out this morning when I knew we were doing this that I've got over 170 kilowatt hours of lithium-ion batteries in a wooden garage next to my house.
Yeah, that's quite interesting.
Quite a lot.
Yeah.
So that's 2 power walls and 2 electric cars, and I trust that nothing will go wrong with that. But I feel fairly confident that nothing will go wrong with that.
You should be. Be. Yeah. I mean,
but it was, it certainly makes you think, though. Particularly when I looked at your webpage, and I understand. I mean, and also I have a friend in America who's got a GM, whichever one it is. I never know which one it is. The Bolt,
I think it was. Yeah.
Yeah, which had and hers was taken back and all sorts of stuff done with it. It's all right. It's never, her particular one has never burst into flames or anything, but they've had problems, haven't they? And Hyundai have as well.
Yeah. So it's you're right to say that the majority of the time that these energy storage systems are quite safe. I mean, the manufacturing of the batteries, the cells, is pretty good. But in the rare instance, you can have a failure of a cell, which leads to obviously what's known as thermal runaway and other problems. And this can typically be in new cells, are not as at risk, but the older the cells, so second life batteries, energy storage systems which had second life batteries in, the risk creeps up as cells get older. Right. And that's I can explain a bit more about why that happens.
Yeah, I would love you to. I mean, I think it's worth, because I just sort of dived in there because I've, I'm selfishly worrying about my own batteries. But I mean, I think your journey to get to what you're doing now is fascinating. I mean, the other things the other areas that you've worked in. So I'm familiar with the land speed record. I've worked with Richard Noble a lot of times. He was on Scrappy about half a many times.
I've got a signed photo from you.
Have you? Was that from when you were working at the land speed?
That's right. When you came down.
That was amazing.
Yeah. So it has been quite a range of projects I've been on. So from Bloodhound, I went to a company called Reaction Engines, and then Williams Advanced Engineering. And Williams Advanced Engineering was where I started working on EVs, so electric vehicles. Right. So they had me down to work on the E-trophy, which was the race version of the I-Pace, essentially. They were doing a one-make race series. So that's where I started working on EVs. So typically, my background is integration. So that's the vehicle control module. So that takes all the kind of parts of the cars. So that would be inverters and motors, the battery management system, and then fuse it together so the driver could control the vehicle, essentially. Right. Yeah. And that then led on to another project, which was an electric airspeed record.
Yes, who we've also done shows about their early development. Yeah.
And I was part of the team there to design and build the aircraft. So obviously a lot of that it's a full battery aircraft. It's not a hybrid or anything.
Yeah, it's extraordinary.
It was in the news recently, actually, because we've just had the records ratified for that project. It has been right,
because I knew they'd done it, but I didn't know it was ratified. Oh, that's good to hear.
Yeah, because there's all sorts of rules and regulations for the actual records itself, which is no surprise, but it takes a while to go through. So it was actually the flights were in November, I think. And so it's been ratified. So kind of a mixed bag of experiences. actually we started looking at like environmental sensors on the land speed record,
Right.
which then led to looking at, you know, environmental factors in the cockpit and things like that. And that was, some of that was gases and things like that.
Right.
That led on to, you know, as I went on, I always tinkered in the background, and I guess coming through these projects, I wanted to come out the other side and, you know, what's next after you attempt a land speed record and airspeed record. And so for me, I wanted to start my own company, basically.
Right.
I could see that there were some things missing that people needed in the EV market. So as a company, it's not just these battery safety sensors that we look at, but other sensors too. But yeah, this one seems to be of particular interest into the EV sector because, as you rightly point out, you know, there's been some issues. As you say, there's not many, but when there is an issue, they're usually quite high profile for the manufacturer. So this fits kind of the bill in trying to catch the early signs of, you know, a catastrophic fire in a car. So yeah, the sensor itself is CAN based. So for people who might not know what that is, that's a communications bus that you have on a car, and it plugs into the communications bus along with lots of other sensors on a car, and adds to the information to the vehicle integrator, basically.
Right.
Yeah.
And that's, I mean, so is it your CAM that gives you the warning light that you've got a brake problem or overheating? Is that what it does? Mm-hmm. Yeah.
Mm-hmm. Yeah.
So I see. So you can build a sensor that doesn't need a whole control system around it to inform the driver or the occupants of the car.
So typically what's done is that you will get sensors, and the vehicle integrator will have something like a vehicle control module, so the brains of the car, that will be looking at the sensor values, and depending on how they want, you know, interpreting the sensor values and then acting upon the data they receive, which, as you say, might be a light on the dashboard or something like that. Yeah.
Because that's, I mean, one of the things in our early communications was, you know, I wanted to kind of, it's only because the occasionally information around electric cars is loaded. There are certain groups of people in the world who are quite keen to delay their uptake, and it is the levels of you know, the sheer numbers of vehicle fires. I mean, because we're kind of used to it that a car full of gasoline or petrol or diesel, you know, sometimes they catch fire and burn, and it's quite often, but there's loads of them. And actually, I mean, I've been driving for, I don't know what, 45 years. I've never been in a car but my neighbours have, strangely enough. That was a few years ago. They were driving the kids to school and they smelt burning, and they got out of the car and it burst into flames and burnt to death. It was a Renault. I'm not saying that all Renaults do that, but that one was a Renault. You know, so that was like not in a crash. It just happened, and that stuff happens. And I mean, you know, and it has happened in electric cars too. It's not that they never do. But I don't know, you know, I only want to say that as a caveat to counter I just had a tweet the other day. I'm not driving one of those death traps. They're always bursting into flames. And you go, well, there's loads of reasons to not like electric cars, but that isn't a very good one.
Yeah, no, I mean, as you rightly point out, it is a very rare occurrence. You know?
Yeah.
It would be interesting to compare the number of combustion engine vehicle fires with EV fires. Actually, I've never really looked at anything.
Oh, right. I sent you some data in an email, but don't worry about it. I mean, it is considerably less per billion miles driven.
Okay.
That's how they've compared it. So, yeah. But anyway, it's not, you know, it's not that it doesn't happen. I think the important point that we need to make is you know, if it can happen, it's a very good idea to do everything you can to stop it.
Yeah, so I mean, this sensor that we have here is not just aimed at looking at self-venting. It kind of, although that's the kind of point that everyone seems to pick up on, it looks at other parameters as well, such as moisture in the pack and just general keeping the cells in a nice condition. And that's also useful for second life applications as well. So, you know, if this battery pack goes off and gets installed in a power wall somewhere or energy storage, you kind of have a bit more confidence that you know, along with the battery management system data, that the cells have been kept under a nice condition.
Right. Because
it's, you know, if you're taking an EV battery apart, how do you know, like, out of those thousands of cells, that they're all going to be good, you know. And
yeah.
So yeah, there is. I think, you know, there's that has also been another interest, that actually for people trying to do second life battery packs, the richer the data set they have on how well was it treated, the more they can sift through the bad ones, if you see what I mean.
Right,
So,
right. Oh, that's interesting.
Yeah.
But can you tell me, I mean, just because you mentioned it then, because I don't know, I can guess what cell venting is, but I don't want to. Can you explain what cell venting is?
Yeah, sure. So as cells age, or if there's a manufacturing fault or some latent fault in the battery, what can happen is that the internal resistance of that cell can be higher than the cells around it.
Right.
As you load the battery pack, that particular cell can start to get hotter than the others.
Right.
Now, if you get it hot enough, the actual electrolyte inside the cell, so you've got an anode, cathode, and an electrolyte.
Yeah.
The electrolyte can start to boil and vaporize, and that's when a cell starts to vent. So the pressure builds up inside the cell, depending on the cell technology. So it could be a pouch cell or a cylindrical cell. In both cases, you will have venting of gases if the pressure gets high enough. And then if that release of pressure doesn't alleviate it, or you don't unload the cell, so you carry on taking energy out of the cell, and in some cases, even if you do nothing, at this stage, once that electrolyte's boiled away, and if it carries on getting hot, it can reach a temperature where it will react with the cathode, which is basically an oxidizer. Right. And one of the biggest problems in EV fires is that once that reaction starts, that is it. You are not putting it out. You're just going to have to stand there and watch it burn. And I think a lot of fire services and things like that are still trying to figure out what to do. It's a new problem, isn't it? And they don't know, when they get to a vehicle fire at the side of the road, if it's an EV fire, there's not a lot at the moment they're going to be able to do with it.
Yeah.
Yeah.
Because even if it sounds like even if you drown the car in foam, which, would put out a liquid fuel fire, it can still keep going.
Right. Yeah. No, it's self-oxidizing.
Yeah.
So, I think one of the ideas is just to literally put it into like a skip of water. I mean, even then, but the water just slows down the rate of reaction, and the energy goes into boiling off the water, I guess. But
it's not the most convenient thing to do on the side of the motorway.
It's not,
can you bring in a skip of water, please?
But I think there's all sorts of ideas floating around about how to actually deal with the EV fires.
Yeah.
On the rare occasion they should happen.
Yes. Yeah. So that's the. That explains it quite well. And I think it's also important to point out that we're not talking about a vehicle that's been in an accident, because that's a whole other area in a way, isn't it? So if the car is involved in a very, that's the early cases of Teslas. I remember reading about it. Tesla catches fire. Oh, it did drive into a concrete wall at 118 miles an hour. Yeah, and the people got out. They climbed out, and it was like, a few minutes later, it burst into flames, and it did burn down. But so we're talking about you're charging it, or you're driving along, or it's parked, and
that's it. I think obviously, as you said earlier, the media, you've got to look behind some of the occurrences of what has happened to actually, find out
understand
what was the cause of it. But one of the other things that we've got as well is you mentioned the Tesla crashing. So, these packs are typically designed for when they go through all the testing, they'll be designed to certain G loading, certain vibration, et cetera. So one of the other things we put in this sensor as an option is an automotive grade accelerometer. Now, obviously, you get accelerometers quite a lot, but this is a high G accelerometer and can trigger information on, if you've over-G'd the pack, i.e. you've parked your car, someone's just driven into it. How do you know if you haven't damaged something with inside the pack? So it can also give you that information.
Right.
Which again helps in second life applications, right? Because
yes. Because we know for a fact that a lot of the batteries that are used in second life applications are from particularly crashed Teslas. I mean, that's one of the because there were so many of them, they tended to be quite high performance vehicles. People weren't used to them, and this is from Norway. Norway is sort of renowned.
Wasn't there that guy who recently blew up his Tesla or something?
Yes, because they wouldn't do something. I can't remember what it was. Yes, he blew it to bits. Well, I think that was that possibly in Norway? It was in Norway or Sweden? It was in a Nordic country.
I think he wanted a replacement battery or something, didn't he?
And they wouldn't give him one.
Yeah.
So that's one source of battery fires we hadn't really
controlled demolition of your car.
If you pack a load of C4 next to it, that tends to do. Yeah, that could be something that starts it going. So let's then go to what you're doing. So that's I understand that potential possibility. So, particularly when you've got sometimes thousands of cells and they're being mass produced on an amazing machine that does it. But I mean, to make sure they're all 100%.
Yeah, right. And
I mean, I think they've obviously got a very high percentage of making good ones. But.
Yeah, right. And so this comes down to kind of really safety critical applications because, like anything, that when you manufacture millions of anything, you'll have tolerances in your manufacturing process, won't you? And some cells will invariably be slightly better than others. Now, when you put all these thousands of cells into a single EV pack, some cells are going to be better than others. So over time, as you build up the miles on the car, or you build up the number of cycles on the pack, some of those cells are going to be aging quicker than the others. Right. Now, interestingly, in typical battery management systems, so the things that look at the cell voltages and temperatures, they don't check every cell temperature. So they check like 1 in 4 or something like that. Now, the reason for that is literally just because it's very expensive and very difficult to put a temperature measurement on every single cell, considering there's probably thousands of cells in your car. So that means you've only got a 1 in 4 chance of picking out a cell that is going to be getting hotter than the others.
Yeah.
And then, so although, they will be aging at similar rates, but there will on, the rare occasion be an outlier, and that one you might not pick up with the BMS. That's where this sensor comes in, because it will tell you if you've had a cell vent, and therefore, stop using the car or get it inspected.
Yes. So, this is something that can be this isn't something that has to be built into the car in the factory, or because that's what I don't understand. Is it something that can be retrofitted, or it needs to be made?
So at the moment, the one we offer needs to be fitted in the pack, but we're keen to put one that isn't, for obvious reasons. It'll be easier to change out, better for the manufacturer, etc., etc. But it's very small, and it's, in terms of like integrating, it doesn't have to touch any of the cells. It doesn't have to. So in terms of mechanical installation, it's quite simple.
Right.
Yeah.
But I mean, so and this is what you're talking about. Then I'm just trying to make sure I understand this, and our listeners do. Is the sensor you're making? Is there a sensor for each cell? Is that
no? It looks at the. It would detect the vented gases.
Right.
Caused by a cell getting hot and venting its electrolyte. Right. It looks at other parameters too. It looks at pressure, because that release of gas will increase the pressure in the pack.
Right.
And then there's other parameters such as moisture and dew point and things like that, which is aimed at just general pack health. So typically, you have, not every car, not every EV has this, but most do. They'll have a HVAC system. So basically a system which allows them to chill or heat the batteries.
Yeah.
So one of the parameters is obviously, let's say you've left your car somewhere cold overnight. Most packs have some sort of breather to air. You go somewhere warm and moist, then you'd have moisture forming on the cells if they haven't heated up, so you get moisture in the pack. So this is something else the sensor offers, is the ability to know the dew point inside the pack, and therefore if you need to heat the cells or not to stop moisture forming in your pack. So it's to kind of a range of things. It looks at just generally looking after your power pack, and is non-intrusive. It doesn't have to touch any of the cells to do it.
Right. That is really intriguing. And I mean, I'm assuming then that, once you've developed this system and you go to a big automotive manufacturer, I'm assuming they don't tell you to sling your hook and go away. I would think they're quite keen to use it.
It depends. You're right. It depends on, I think it depends on their safety case. That, as you rightly point out, I think it's important to point out that this, is quite a rare event that you should get a problem with the cell. Nevertheless, they can happen, and I think some people, it doesn't cost a lot of money to add this extra bit of information to know. We are speaking to several manufacturers of different types of vehicles, of public transport, and cars and things like that, for integration of these sensors into the pack. So there seems to be quite a lot of interest. It's good. Yeah, right. I mean, we started off providing it as a development R&D sensor, and basically someone came back to us and said, can you productionize this? So we're in the middle of productionizing it at the moment, and we've had some quite good uptake. No one's told us to go away. What are you talking about? I mean,
that's very encouraging.
Subjects, but
but not on that. Yeah. But then that is, and it's also important. And I have to remind myself, and that's a really good reminder you've done that, is that, the show started out focused on electric cars, but actually what's very apparent is public transport delivery systems, vans, small trucks, buses. They're the numbers of those are increasing. If you look at the uptake of those, that is proper hockey stick. It's just going off the scale. Yeah. So there's so many more of them appearing on the roads, in greater numbers.
I guess it's easier for them, isn't it? Because I say easier, but for a
bus, they have if you're doing set routes, it's not like, and dustbin trucks. We've just been doing dustbin trucks.
They know where they're going. They know how much energy they need. They know when to charge it. It's not like you or I who get a call and
might go all over the place. Yeah. But then I think that what that is, I can tell that's the system that you're developing. You can imagine that being adopted by, as the technology improves, that will just become the standard. It just makes so much sense. It's such a really good solution to that potential problem. But I'm very interested in is the second life, because I think it's a vitally important part of the whole transition in a way.
I don't know the numbers exactly, but it takes quite a long time for your EV to become carbon neutral, doesn't it? So if there's anything...
there are huge arguments. It's between 7, that's the smallest, 7,000 miles, so roughly 10,000 K, to 800,000. But I think I'm going to go... that was what I read a paper that proved that you had to drive over 750,000 miles because it was so bad. And you just go, shut up, move on. So it's certainly, it is. It is not. It's the difference.
Can you imagine, let's say everyone has an EV.
Yeah.
Well, it's just a looming problem of what are we going to do with the batteries at the end of it? And if you can have a use for them,
Yes. Oh, it's essential. It's essential. I mean, the two essential bits are second life usage, because they're, I've recently replaced the battery in my Nissan Leaf with a Nissan Leaf battery from a crashed car. So now I'm slightly more anxious about that than I was.
Be fine. It'll be absolutely fine.
It wasn't badly damaged, and it's been safety checked and all that stuff. I'm sure it'll be fine. But that's one part. But the old one that was taken out had about 18.5 kilowatt hours of usable, perfectly decent batteries, which have been repackaged into a trolley that you can plug in and run things off. Fantastic that it's not being thrown away. And 18.5 kilowatt hours is a lot. That's a big pack. But it started out as being 24, and we'd really damaged it. We'd done all the worst things you can do to batteries, and of course it was first generation Nissan Leaf, making all those caveats, but. We've got to be able to do that. And then, so the really critical thing is, and we've been to see companies that are repackaging car batteries as energy storage systems and going through incredible safety checks with each cell. So there's someone testing each individual cell, and they're using thousands of them. It would be such a good thing to have a system that could monitor that, and run it safely, which is what I think is that a different system, or is it essentially the same thing?
It's the same technology, right. And we are developing in interesting you say it, like, because I think the second life market, I mean, if you look at where the risks increase of problems with cells, it's as you get into second life, and not only that, I think people using power banks in their houses and things like that. That's just going to get more and more, and that's probably a bigger market than the EV market itself. So I think
it might be one day. Yeah.
And so yes, we're using the same technology to develop an industrial version of the sensor,
right?
Which is aimed at energy storage systems.
Yeah. I mean, particularly, I suppose if it's I'm going to go and see a battery soon that's 40 megawatt hours.
Wow,
that's quite. I mean, it's a grid battery, but
where's that?
That in Oxford. It's only it's in a car park.
Is it? Is that
not a Culham? No, it's in, like, I would call it Iffley from when I used to live in Oxford. Probably isn't Iffley. It's southeast Oxford. It's a national grid installation where there's a car and an old park and ride car park. They've taken some of that up, and they're putting in rapid chargers as well. So the rapid chargers take the power from the battery, but the battery is really for grid balancing.
Yeah. I mean, that's a serious amount of energy.
That is big, isn't it? Well, the one in I've got to get those numbers right. The one in the South Australia, that was the first big Tesla one, is nearly 500 megawatt hours. I think it's 460 megawatt hours or something. Wow. Which is mind-boggling. It's just but I think that's just going to become quite commonplace. It's not. Certainly it's an application, isn't it, for them? So. Yeah, and certainly if you can imagine, if you've got, it hasn't happened yet, and all the people that we've talked to about who are doing battery recycling, as in total end of life recycling, they're practicing on phones basically and laptops, because there's very few car batteries we haven't had electric cars long enough for there to be a massive pile of them that we need to recycle, So I think that will happen. But that means I think there's a long, all the indications are, once you take a battery out of a car and put it in a box on a wall of a building, the strain on those batteries is massively reduced to what it was getting in the car.
It's all about, so your battery management system in a car. In a car, obviously, the mass of the car, the cost, and them trying to maximize, I suppose, the effectiveness of the batteries. The battery management system in a car will, allow a maximum depth of discharge of the cell, maximum charge. So although you might see on the outside, on your charge bar on your car, you might see 100%. Typically, the manufacturer won't actually do that. They'll be only actually going up to 95% of the cell's capacity, or something like that, depending on the life. When you look at different cell technologies, they have different lives, different number of cycle counts and the degradation rates. When you go into like energy storage systems, they're just a lot gentler on terms of what is the maximum state of charge that they'll go up to, and what's a minimum state of charge, and also the temperature ranges and things like that. So they're just not worked as hard.
No. But then, I'm just trying to work out if you have explained that, how the sensor works, because there's clearly, like I have a Tesla Model 3, it's festooned with sensors, which are mainly distance and sort of local. I don't know what you'd call them, but they, so if you drive near a tree, it tells you you're near a tree.
So it will sit inside the air column, somewhere in the air column of your battery pack,
right?
Your EV.
And when you say the air column, is that the gap between the cells and the outer wall?
Yeah, right. If you like. Exactly that. Yeah. And it will sit there monitoring the gases, temperatures, humidity, air pressure, and those parameters together can help you figure out if there's been a cell vent or not. So it's as we spoke about earlier, it's non-intrusive. It doesn't need to touch the cells. It doesn't need to. So for any manufacturer, the important thing is they don't need to change anything. They just need to be able to put this thing on their CAN bus. And have because it's very small as well, just have a very small gap somewhere where they can actually place the sensor.
Right.
So I'm sure, you know, it's we're targeting kind of younger, smaller firms because they're easier to. They seem to find it easier to make engineering changes in their pack design and things like that. Because obviously you've got to put a mounting hole here or something like that. Something has to change, maybe not a lot. And it's the smaller guys that seem to be more readily able to make those kind of changes and introduce them. But we're hoping that will percolate down to the bigger guys.
To the big guys. Because also, so it's not something that's going to increase the vehicle weight by any means.
It's like 20 grams or something.
Oh, I see. It's really tiny.
Yeah, absolutely tiny. It's to give you an idea, it's about the size of a matchbox, probably.
Right. Yeah. So it's not a big. It's not a difficult thing to fit in. And would that be the same if you were doing not necessarily a grid level battery, but a household battery? Second life pack, it would be a similar thing. It would
be really, really similar, but typically they don't use CAN bus in houses.
No.
Some do. Some people do, but it might be Modbus or something like that. So it's pretty much the same. The interface to connect it to it depends on what you do with it, but usually people have some sort of gateway to the internet to check on things.
Yeah.
So,
So
it would sit on a bus, usually a mod bus.
Right.
It could be CAN. I've seen CAN.
And I suppose the next step is just say, let's go with a battery on a wall of a house rather than in a car, because I can imagine you've got. A warning light comes on in your car and you go, that's really serious. I need to do something about that. But what do you do if it's in your house and you get the warning?
I mean, you know, the sensor aims to pick up cell venting. You know, stopping loading on the pack can help avoid a thermal runaway. It doesn't necessarily mean that you will, but it will help. What it will definitely do is give you time, right? It will give you time to do something about it.
Yeah.
For installation into buildings, if that's, I think that's what you were just about to ask me about. So the aim is that these would sit on, usually if you inspect your power wall or whatever you've got there, you'll see some sort of breather point on it. It might be quite well blended into the design, but there will be some sort of port which is open to the air.
Yeah, and it's sometimes when it's either very hot or very cold, when you go out in the garage, you go, what is that? And it's there's a fan. So it's being,
so you typically put it near there.
Right.
And your power bank probably has, I mean, the ones most of them do probably has an e-stop on it, so an emergency stop that will just disconnect it from the system. So the industrial version of the sensor aims to activate the e-stop on that power wall or whatever it might be, you know, whatever energy storage system you've got. It depends on what the integrator wants to do. So for people in houses, that's probably what they want. For somebody who's doing, you know, we're talking about actually energy companies, they might want to integrate it into their data and then decide what to do and integrate it into the fire system and things like that. So it just depends on who you are, really. But homeowners, the aim is to put it near or on their power wall and then interrupt the e-stop should it pick up the problem.
Right. And so what you hope at that point is it just calms the whole thing down. It's not going to get any worse, but you kind of then need to have a look, see what's going on. You need someone to come to your house.
Yes, exactly that. Yeah.
I mean, is there if you were to say, you know, I've seen lumps of Tesla batteries, which is like a plastic tray with hundreds of cells in. Would you be if you took the lid off that and looked at the tops of all the cells? Would you be able to tell?
It would be.
It's that one there.
You know, it would be quite difficult. You'd have to really. Sorry, you could do that. And you might get lucky, and you might see it, right? But depending on where it's vented and how violent the vent is, and other things like that, you might not see the witness marks, or might not be immediately obvious.
Right.
The other thing you've got is cell data, so you could have a look at cell voltages and look at any fluctuations in cell voltages. But it is a complicated problem because if you've got a lot of cells in parallel, right? So they're all connected in parallel.
Yeah.
If one of them goes, it's propped up by all the other cells. So the actual fluctuation in cell voltage might not be very very big,
Right,
depending on your
right.
pack architecture.
Yeah.
Right. And then you've got like temperature sensors. So although typically not every single cell is temperature sensed, you might have a look around it to see if there was a build-up in temperature caused by that cell.
Right.
You could look, basically, you could look through the forensic kind of data off the pack and try and figure out where it was. But it's a difficult problem, admittedly.
Yeah.
You know.
And I mean, it takes, we've sort of certainly thought about, cars, delivery trucks, buses, that it's kind of essential for all those things. But it's the kind of what's clearly happening quite soon, much sooner than I ever expected. It's if you're in an aeroplane and there's a problem with the battery. I don't know why. It's maybe just my fear, but it feels like it takes on a whole new level.
Yeah. So they obviously, that's obviously, I think that's in the minds of most people wanting to do electric aircraft.
Yeah.
There's certainly seems to be a drive in aerospace to prevent thermal or contain thermal runaway. So structure. Yeah. So it might catch fire, but structurally it's going to be okay, kind of thing.
You've got time to land before anything bad happens.
So any additional time you've got to make decisions helps you. So even if so let's say the problem with the plane as well is, as you rightly point out, depending on the system architecture of the aircraft, you can't just turn off just turn off an engine. Do you know what I mean? It is quite a tricky safety case that you have to work through it. What is the logical steps that you take to land it, basically? Yeah,
because I mean, if you were in a car and it actually started to burn, you'd smell. Well, as we know, this happened. You'd smell it. Might be smoke in the car. You stop the car and you get out quite quickly.
Depends how far you are from the services, doesn't it?
But I mean, you can if I smelt a lot of smoke and felt my bottom getting hot, I'd get out of that car really quick. Don't care where I was. Sit in a puddle. But on a plane, obviously, that's very different. So that must be. I mean, are you in? I don't want to know any proprietary information, but are you in communication with? There's numerous companies in the UK. And you worked on the Electroflight project. But
there's some people who are in. Yes, it is again interesting. I think for them to look at their safety cases. How do they make it as safe as possible? Yeah. I mean, going back to your question over when a cell, let's say it detects a problem with the cell, or how do you know which cell it was, and can you repair it and stuff like that? I mean, on bigger vehicles, what you typically see is that it's not just one big battery. It's lots of kind of modular type batteries. So yes, you might not be able to pinpoint the cell and replace the cell, but you could replace that pack unit. And you wouldn't have lost the entire cost of all the batteries in the actual pack, if you saw. Yeah,
and you can imagine that's actually, I would think, is easier, strangely enough, in an aircraft than it is in a car. That you could have a sort of modular battery system that is replaceable from outside.
It's all about making money, isn't it? It's like, what's the turnaround time on the ground? All this kind of stuff. Do you have time to charge it, or do you change the packs out, and all these problems? New problems for that kind of emerging sector to solve. Yeah.
And then there's shipping as well, which I noticed on your website. You mentioned that because that's something we're hopefully seing this year in Amsterdam. Well, we've seen a few electric boats, but when they start to get big, so there is what I would have called a coast. Is it a coaster? A ship. It's big. It's not a boat. It's a ship that has 7 or 10 megawatt hours of batteries.
Wow.
And it's going along part of the Norwegian coast. Yeah. And it's moving, I think it's fertilizer. We've featured it briefly on the show. So, and it was normally trucks that were doing that journey, and they can just get rid of all the trucks because it's bulky, heavy stuff. So they don't need trucks. And the truck journey was really arduous because it's the Norwegian coast, so it isn't straight. And this thing just sailed. And it's only sailing 20 miles or something. It's not that far. It's not going to cross oceans, but they can charge it at either end from their wind and their wind resources. I mean, that is an amazing thing. But then that is a huge, that scale of battery is vast. And
I think as the you know, because would it be fair to say it's still quite a young technology?
It's incredibly, very young technology.
Obviously, kind of automotive have been the first to kind of come into it. Even if, you know, because you've got it's a lot of it is horses for courses, isn't it? So in some situations, an EV solution might not make the sense, but a hybrid solution might, or something. You're going to end up with batteries somewhere on these things, usually, and if you've got that, then, you know, you're right. It's pretty much cross sector, anything with a battery. You know?
Yeah, which seems to, I mean, because that's one of the occasionally amusing, sometimes annoying, but, you know, very realistic things when people say, oh, hydrogen is the future. I've driven 4 hydrogen fuel cell cars. They're all brilliant. They all had quite big battery packs. They have to, you know, and the same with we've looked at an aircraft, Zero Avia company, and that's a hydrogen fuel cell plane effectively, and that is what makes it go. But it's got a big, chunky, heavy battery pack.
State the obvious, but it might not be, you know, obvious to everyone. But you know, you've got to soak up the transients. So hydrogen and hybrid stuff, you know, they're all designed to operate at their optimum efficiency. So if it's a combustion engine operator, whatever the most efficient RPM is, hydrogen. Problem with hydrogen fuel cells is that you can't. They're not great at soaking up transients. So if you put your foot down, it takes a while for the thing to react. So you need something to take care of the transients, and that's batteries, isn't it? So even if hydrogen is a goer, you know, at this point in time, unless you can somehow solve the problem of taking up those transients, you're going to need something to replace it. That is batteries, isn't it?
And I mean, there is 2 people we've been to see now. Skeleton, who are a company in Estonia that make, I'm going to make sure I use the right one. I think it's ultra capacitors, and they were extraordinary. So they are cells the size of a can of beans. But I'm wondering, is there potentially the similar problem? I mean, could you get thermal runaway in an ultra capacitor? I never even thought of it before. It's not a question we asked them, which is annoying.
I say batteries. No, you're right. In some applications, supercapacitors, that type of technology, I suppose, is also a possibility. I don't know. I don't know.
Sorry to throw that one at you.
No, it's a really good question. You should,
because it's a similar. I mean, we saw them being made, and it was just bigger than any of the cells I've seen. But the actual makeup of it, it's a coiled up material that's put in a can. You know, to put it in its most crude description. You know, so in that sense, it's very like a Tesla cell.
I mean, I don't know. You know, typical capacitors are. Don't really have an electrolyte like a battery does.
That's what I don't know. If they have an electrolyte.
I don't know enough about that technology to be able to comment it, unfortunately. But
and also, I mean, one of the key things that I do remember from it is that its charge and discharge cycles are off the scale. It's millions. You know, it isn't affected by it in that way.
I don't think it. You know, at the heart of it's not a chemical reaction. You know, like a cell, like a battery has a chemical reaction which gives you the electromotive force, but the capacitor works in a different way.
There's a company in Wales which you may have heard of, River Simple, who are developing hydrogen fuel cell cars, but they don't. That's what I remembered it is they don't have fuel cells; they have ultra capacitors, and that's how they get round that.
Interesting.
That system. But that's been going. That's been being. I mean, I really wish them well, but my goodness, it's been going on a long time. You know, when they're about to do it, you know, it's one of those frustrations of, you know, I really want them to succeed, but at the moment, it hasn't made that kind of big leap.
It will be. You know, you talk about hydrogen and aircraft. It will be interesting to see the use cases of these things, won't it? But it's still very young.
Yes, it is. But I mean, it's a fantastic sector to be in. I mean, at the moment, are you optimistic of the business opportunities you have in this sector? I mean, it's going well?
For myself or for the sector itself?
Oh, no, for your company. I mean, yes, is it?
Yeah, I think to be honest, the aviation sector is quite quite a small set.
Oh yeah, no, I mean in general, not in general terms, in not general, just aviation.
Yeah, absolutely. It's been, you asked earlier, but yeah, it is nice. You know, when you're trying to sell something, it's nice that it's not a hard sell.
Right.
It is a people are, oh yeah, okay, yeah, we could really use that. And typically, you know, we're in conversation with lots of people. There hasn't been a conversation yet where it's been, oh, actually, thanks, but no thanks. So I think, you know, the cost of adding this thing is so low, and the extra information that it gets you is quite important. You know, it forms part of the forensics that you need to figure out problems. Typically, it's not just one sensor you need an array to figure out kind of stuff. But yeah, it's been really good. So I am quite hopeful. Yeah,
oh, good.
We'll see what
and
happens.
I mean, that's I kind of like to wind up on this just because it's such a common topic at the moment, particularly in the fields of electronics. I'm just wondering how much of the sensor you make in this country. I mean, do you make most of it, or is it, you know, it's the China question?
It's it's a fair question. So I think where you, from what I've seen, you know, typically the sensors themselves, the technology behind the sensors, that tends to be it's a European company actually,
right?
But when you know, sadly, when you go to look at price points for manufacturing sensors, and also it depends on what your customers want in terms of quality assurances.
Right.
So typically, you know, you'll do your electronics assembly, so that would be putting on the components on the PCB in China. Probably what we'll do at the moment is assemble it in the UK and do the quality checks here, so the final integration. But yes, the PCB manufacturing assembly happens in China.
It does happen, yeah.
The actual sensors and a lot of the chipsets on there are from different vendors, which are all over the world. So, you know, there's not just one part of this puzzle when you're designing stuff like this. But yeah, you're right. You know, the assembly of the PCB happens in China.
Can you just for dumbos like me, because I've forgotten what PCB stands for. I just think it's always worth.
Board.
Thank you. It's so obvious now.
It's okay.
I feel
even
more stupid.
No. I'm just really.
I just think
I've got this nasty habit of being able to patronise everybody. I don't mean it.
It's not your fault.
It's not
at all. It is absolutely understandable. You know, using 3-letter acronyms is so normal.
Yeah,
and it's not.
I use all. I'm sorry. Yeah.
But I mean, it's just a habit I've tried to develop to make sure
You're right.
ask what those things mean.
The number of things I read and like, what is that? There's too many acronyms.
Yeah.
In this.
Yes.
Yeah. Because Elon Musk doesn't. I don't know if this is true, but he doesn't let people put acronyms down, does he? I thought he's like, stop putting acronyms everywhere. No one understands what anyone's saying.
That is one of the best things I've heard him say, because he has said some incredibly dumb things.
Yeah, I mean, I could be wrong. I mean, that's second-hand information, but I swear that's something
I haven't heard that. But
yeah,
that sounds all power to him if he did say that. No, it is, but it's also, you know, when you're talking to your team, if you've got to say printed circuit board 55 times in a paragraph, it's kind of very understandable.
And no one wants to talk about electronics.
I love a printed circuit board. No, that is brilliant, Joe. I'm really impressed with what you're doing, and it's always good to hear about a company that's starting up in this country. You know, that is one of my little, and it's not new. It's not. I've been going on about it for 20 years, but that. You know, we had this incredible heritage of making stuff in the UK, you know, in the Industrial Revolution, basically. And I just think it's such a shame that we're not still doing it. And I want more engineers and scientists than YouTubers.
Do you know what I think? When I'm in engineering, I've met some really excellent engineers. You know, and it's not just the theory; they're good at the practical, and that is how. That when you know the practical, you can apply theory to the practical and come up with some really good solutions. I just think a lot of people that typically those clever guys that you meet, they have a lot of self-doubt, and it's a real like, you know, because they're quite introspective, quite intelligent. I just wish we could teach people to perhaps be a bit more confident and go and try it. Go and have a go. What have you got to lose? Just like, go for it, basically.
Yeah. And at the moment, as you are a very good example of, there is a whole new world of potential opportunities and technology that's developing at such a pace. It's not like even 30 years ago, you might develop a new distributor for a spark plug. Well, do you know what I mean? Everything was developed to a great extent around all the kind of those basic mechanics was sort of settled. I mean, what can you do? You could have a different input valve mounting seat in an engine or something, but basically,
I mean, when you look at the tools that are available to engineers today, so the CAD tools, the modeling tools, so the computational fluid dynamics, the stress analysis, designing of electronics, 3D printers, all these things, microprocessors, the ability to quickly get hold of them. Really, the only limit is your imagination.
Yeah,
what you can do. It's just there's just so much out there in terms of tools to be able to design and make stuff. It's just what problems can you solve? It's
that's a very good. I think that's a very good, excellent point to end on. Though that is brilliant, Joe. Thank you so much.
Thank you
for your time, and good luck with the company in the future. And I hope that when I one day get a second life battery pack on the wall, it'll have one of your sensors in it, and I'll sleep fractionally easier.
I hope so too. I'll put my face on it. Yeah.
Thank you. That would help. Okay. Brilliant stuff. Thanks so much, Joe.
Thank you very much.
Well, I really hope you enjoyed that. It was a joy to talk to Joe. What a lovely guy. What a brilliant stuff that he's doing. How important, kind of really, a really important thing. And those, the sensors I can tell they're going to be fitted in battery packs, and, it'll just become a normal thing. It makes so much sense. And as he's said repeatedly, it's pretty rare, but I'd much rather something that's pretty rare, that's really unpleasant, is rarer, and you can do something about it. Let's make this new technology as safe, as sustainable, as recyclable as possible. Those are critically important things. That's all. Do subscribe, please, to the Fully Charged Plus podcast on whatever download apps you use, or on YouTube, as it's on YouTube as well. You can have a look at the Patreon link. No pressure on that at all, but obviously we'd love it and appreciate it if you did. There's YouTube memberships on the main channel, Fully Charged on the Fully Charged Show channel. That's it. As always, if you have been, thank you for listening.